Is this working?
Welcome everyone to, oh, I'm not ready yet, I think. Yes, it was working. All right, welcome everyone to this week's IPLD Sync meeting. It's May the 23rd, 2022. And as every 2 weeks, we talk about IPLD things and go over the stuff that we have worked on and then discuss any open agenda items there might be. I need to open the HackPad, so we also take notes. I can also post it in the chat. It's the same page every week, so you can bookmark it. So yeah, so we start with the updates. So first on my list is Aline.
Yeah, so not a ton on my side. I've been working on some of the WASM IPLD things when I can. I've added support for directories, using like the BitTorrent v1 directory as an example, because it's just a little bit miserable. Like it's not super easy, but but not as miserable as it might be if you were doing some of like, you know, the Bitcoin stuff. And yeah, seems to work. So this gives us like recursive. So we have large bytes and we have large directories. I've been learning some Rust as I go, which means that this is becoming easier as I do more of it. The Go bindings are still a work in progress, but right now the Rust stuff works and has tests and fixtures and such. So that's a start.
Thanks. Next on my list is Tao Sheng. I hope I said the name correctly.
Okay. Because I'm from KingLabs teams, we have studied the poetry for the past months, and we have discussion meeting with MOV for IPLD truncatory and IPFD poetry. Even that we have studied this poetry last year, but now we are studying the poetry again, and we want to try to find a solution for IPLD indexing, or indexing for the IPLD data structures. And we have studied the ruling hash and the poetry related stuffs, and we want to find a solution on how to build indexing on the IPLD. And we also need help and need advice or supervision on how to proceed on the IPLD indexing. For example, we can build the IPLD specification based on poetry from scratch, and or we can build the indexing on the existing IPLD data structures. We need your advice or helping on that. Thank you.
Cool. Are you working in Go or in JavaScript currently?
Yeah, we are studying that project, and the JS implementation of the poetry, we are doing study on that.
Okay, cool. Yeah. Yeah, I guess Morph will be the best one to talk to about all this stuff, who sadly isn't here today. So normally they join every 2 weeks, but I don't see them today. But yeah, normally they are here. So perhaps next time they will be here.
Okay, I see. We can have a separate meeting.
Yeah.
With mobile.
Yeah.
Okay.
Good.
Thank you.
Okay. Thanks. So next on my list is Rod.
Okay. So a bunch of things. The main highlight is this first one, which is pull request number 414 in Go IPLD Prime. And it's a custom typing thing. So the challenge with bind node that we keep on bumping into is the it's a fairly typical Golang marshal unmarshal problem of you have a basic type that you want to marshal and unmarshal, but it's not the type that you want to use internally. It's something that's specific for marshalling and unmarshalling. And so you end up with these multiple layers of data structures to get to what you want. And this is particularly chronic inside some of these more nested data structures where you can't, like something down very deep in the data structure is the piece that you can't use the native the bind node thing for. So you have to then rewrite the whole data structure and then have a whole mapping thing that deeply nests it all. It copies it back and forth, and that's kind of frustrating. And it just makes the API, it's nice to be using Go types and not have to have the node interface or do code gen, all that sort of stuff. But it's it ends up being very verbose in having to use it, and so you end up having to have this separate little package to do your conversions. Anyway, so this first pull request here, the 414, there was 2 pull requests that's merged into one now, but the idea behind this is that you can define custom type converters for specific types within your bind node usage. So then the intention is that you would do that for types that don't naturally, that do something a little bit extra above the sort of the base data type. So when you're looking at something like the classic one is a byte slice. So when you have some bytes and you want to convert to a big int, that's not something the bind node can do by itself because it doesn't know how you want to do the big int conversion. There's multiple ways to do it. And in fact, Filecoin has multiple ways of doing big int conversions. And so you would define a converter that says, this is a function that says that when you give it bytes, will give you the thing that I want. And then the reverse, when you give me the thing that I'm converting from, I'll give you bytes. And when you've got those 2 functions, you can register it as a type. And then whenever bind node encounters that type, it'll invoke your little converter function. And then that also works now for any. So in bind node, when you encounter an any, it gives you the whole data model node with whatever's hanging off it. Like it could be as large or as complex as it need be, but you can do the same thing now for any. So you can use this to wrap all sorts of custom things behind a data model node, which is useful for a couple of awkward bits in the way that Seaboard Gen is currently used inside Filecoin. So anyway, long story short is that this gets us really close to being almost Seaboard Gen compatible. There's only one little awkward area that makes it difficult, but the any conversion makes that so that the change is minimal. So what you can do, and I've got in that second pull request on GoFill markets to demonstrate the use, is when you're doing a conversion from Seaboard Gen to bind node, you can actually run Seaboard Gen and bind node on the same types with minimal adjustment, and you can test unmarshalling and marshalling between them so that you actually have binary compatibility. So anyway, that's I spent a lot of time on that last week, and I'm pretty happy with that. I think the performance is not the performance impact is fairly minimal. On top of, like, bind node's got it does some hard work anyway, but yeah. So I might merge that soon. It's all marked as experimental, so liable to change. But yeah. So the next thing is pull request 414 on Go IPLD Prime. Let me just see. Is it the one I was thinking? No, not 414. Sorry, give me a second. I've got to find this. I was writing this as I was. So, okay, it's pull request number 413 is worth noting. Now this one is one of the problems that the IPLD prime has is its use of integers is int64, which means that you don't get the full uint64 range, which you can do in CBOR and JSON. So our encoding formats, and I think even presumably you could do it in DAG-PP, not that that would be useful, but you miss out on that little bit of range. And currently it either does in a couple of different places it encounters this, it either does an overflow or it just, it either errors or it actually just overflows and wraps around. So you get a negative number. And this is a problem in where we're encountering some real data structures that use that range, particularly in the Filecoin chain, where that full range is used. So this is a proposal for how we can get access to it in the places that we need it. So where you know you need it, this is a means by sort of hiding it in the data structure. So if you know that in this position I need a uint64 and I know I need the full range, you can actually get access to it. So it's wired up to the DAG CBOR codec. And I haven't done the DAG JSON one because that requires some deeper work in the JSON decoder. But yeah, that's there's a couple of places I might need this. So for now it's marked as draft, but it may end up being used. But if anyone's got feedback on that, that'd be great. And that's me, I think.
Thanks. Next one is Musin.
A question for Rod on that one.
Yeah, sure. Go ahead.
So it sounds like part of what you're trying to do is expose like sort of these optional ways of getting like a few extra more bits that weren't there before. I'm wondering if like there's either an interest or like a pattern where we can do this where like each time someone wants a few more bits, it's not like, oh, can I have like I want a U64 encode. Can I have like a U72 encode and like a U90 encode? As like I start expanding the number of bits I want, people want larger and larger like big int sorts of things. How we do that, like maybe in this case it's like, this was just an oversight beforehand and we're just like fixing an oversight. But it feels like the data model support, in theory supports like unbounded integers and negative integers. It's just a matter of like what the libraries currently feel like exposing.
I think the data model is heavily informed, even though Eric might deny it, it's heavily informed by the codecs, and both the codecs and the programming languages. And so CBOR numbers are 64. They're unsigned 64, both positive and negative, which is interesting. And there's no means of, we in our DAG CBOR spec, we don't allow the use of big int of any of those extensions that you would use, tags. So currently we don't have a means by which we can encode and decode, but we get around that in Filecoin by using the big int stuff with bytes. So I would say right now there's not a practical means to exposing more unless we had a codec that would allow us to encode more.
I mean, like you could have you could see like, instead of doing some of the like custom decoder stuff we're doing, you could also see like, I have an ADL called like big int,
right,
that like takes a chunk of bytes and like turns it into a big int for you. I don't know, that doesn't seem super crazy because it feels like sometimes people are going to want integers bigger than.
Yeah, I mean, you could like what is it, Rust just got the 128.
Well that's just a way of saying like we just chose a bigger cutoff point, right?
Yeah,
we just started 128, that'll do the job for us, it's bigger than 64.
Well, and and then there's some code bases like the Bitcoin code base that defines a uint 256 for the hashes. In theory, you could do that too. I don't know. We're working within constraints of programming languages as well. We have to be practical about that. Like Go has uint64 or uint 64 as its biggest thing. And Go IPLD prime is a Go link, is a Go binding. So, I mean, the question is interesting. Can you expose something that is a bit more generic than this?
And if it's a good idea or not, right? Like if this is going to keep coming up or not, I don't know.
I don't think it is, because this one's a very specific case of there's a few bytes that we don't have access to right now that we kind of need to. Seaboard Gen will do it. IPLD prime won't. That's a gap. But I don't think that, like, and this is really informed by the codex too. So,
Okay.
Good point on the ADLs though.
Yeah.
Worth a think.
Cool. Thanks.
Yeah, I think it might come up, at least in the Rust sort of things, when we're doing, or I do more of the lurk work, because like in cryptography, you have begins, like you always have begins. And so I have no clue, like I actually haven't thought about like how they currently represent those things. Because like ideally, yeah, it is in the IPLD data model, it's an integer, so it should work, but practically will be interesting. So yeah. Perhaps there we can push.
For what it's worth, for like the codec that I've been using is like the transport between WebAssembly and Go. I just decided to encode integers as like varants for as big as your language feels like shipping them out. It's like, yeah, I mean, if the other side of the programming, like if the other side of the environment only knows how to deal with 64 bits and you sent it 80 bits, it's gonna have to error. It's gonna have to like error at you or something, right? But like, the codec might as well support it. It's not that hard.
Yeah. All right. Next on the list now is Musin.
Thanks, Walker. Yeah, I have made some more progress on the update implementation, trying to fix the bugs that I knew of, finding more, fixing them. Rod gave a comment, so I have reworked that implementation as well. I should be close to having all the fixtures, the current set of fixtures pass, and then hopefully I can add more. I have a few ideas of how to make it more generic, so that someone else can add their own implementation based on the template, if they want to replace it, whatever. So I'm going to keep working on that. That's it for me.
Cool. Thanks. All right. That's it for the updates as far as I can see. So is there anything else people want to discuss, or they want to introduce themselves, or if they just have another topics that came into mind, feel free, we still have time. All right, it doesn't look like it.
Were there concrete questions you wanted to ask around the poly trees or the chunky trees that you wanted to like talk about? Or more like wait for Mauve for async thoughts?
I think you could give us some suggestion on how the research direction about the polytree.
So Michael Rogers's implementation is probably the most interesting to look at in terms of implementation. Yeah, that's right. The polytrees. We do have the parallels of stuff that we do have that is currently used is the HAMPed work, and you'll find a JS IPLD HAMPed library. Is that in mine or is it in the IPLD repo? Let me just see where this repo is. I don't know where it is. That's interesting. Oh no, I called it a hash map. That's right. But nobody agrees with the naming of it. Okay. I'm going to put a link in the so this library is a usable data structure that some people are using now, that is in JavaScript, that implements a HAMT, and there's a second library behind it called IA map. The nesting of the libraries is a little bit complicated. If I was to redo it again today, I'd probably flatten it a bit more, but this was very much a research phase when I was first doing this. You'll want to present an interface, either something like that, some cross between that and Michael's ProlyTrees interface to make it usable. We have this problem in JavaScript of not having a clearly defined API that's consistent across libraries, unlike in Go. So it's really, what can you present that is practical and usable? And that's probably going to be a matter of experimentation, using what other people are using, and then considering what people want to, how people want to consume it. The thing that's held me up with ProlyTrees is the ongoing concerns with the ease of collisions, or the ease of generating either collisions or non-collisions. So they're nice if you are dealing with purely random data, but as soon as you allow users anywhere near the ability to define your keys, you get into this problem of having potential overflows of block sizes, or underflows of having lots of tiny blocks, which is a perverse case that you don't want. So that's been my hang up with ProlyTrees that I keep on coming back to whenever I think about this problem. But I know some people are using them in practical ways to and hiding it behind a bit of randomness. But yeah, when you want sorted data structures, you kind of want them, you also want them to be safe. So I don't know, it'll be interesting to see more practical use and considering some of the potential attacks on them. That hasn't been, not much work has been put into that. Yeah, I don't know if there's anything, like, is there anything specific that you want to ask about?
Yeah, thank you. For the specific use of poetry, we think we want to build, for example, the reading side of the IPLD data. We need, IPLD. I mean, poetry is using the ruling hash for on the blocks. They have different organization, different data structure organization based on the blocks. That is different from the IPLD Merkle-tree, IPLD Merkle-DAG. That is difference. I see. Our question is, need we build a totally new specification based on poetry for IPLD data structures?
You mean you've got like a custom encoding, a custom data encoding format? Is that what you're talking about there?
It's not encoding. I think is I think that is we need to build a new Merkle-tree data structures on the blocks. The poetry is using the ruling hash. They will have different block numbers on the leaves, on the B-tree leaves.
I'm not sure exactly what the question is, but the other resource I should point you to is, I'll put a link in the doc, a specification for the HAMT, which is implemented by that hash map library, and we have a similar one in Go. We have a couple in Go. Actually, Edin just put the note in chat as well. That if you go through that specification, that's the kind of thing we will need for the ProlyTrees implementation, and maybe that's what because I know Merv was talking about getting that written up in some way. So that description tells you how to implement, or how the HAMP data structure, multi-block data structure is implemented, and what the interface looks like for various operations of it. That's the kind of thing we'll need for Prolly trees, and that will be particularly interesting to then be able to talk about some of the positives and negatives and the weaknesses of it.
Okay. I think we need to look into that and go back to you and discuss further.
Yeah, if you read that spec, that it's the Prolly trees has the same kind of process of, this is how you build the data structure underneath it. This is how the blocks lay out. So when you're adding things, this is how it shakes out. And then when you're reading things, this is how you would get access to them. So that doc tells you how to do that for a HAMT. And the Prolly trees is a fairly similar in the patterns.
Okay.
Yeah.
Great.
Is the Go HAMT implementation of that like a reasonable thing to look at as an example, or like not really?
Will would be the best person to answer that question. I think the Go HAMT implementation is close, but not really.
Yeah, the Go HAMT implementation is pretty reasonable as an implementation.
Okay. So let's get a link to that. That would be, I'll put that in the doc as well. Yeah, there's the Go version of that, and just for completeness, I'll put in. There's also there's a second one that got spec'd out called Vector, which is like a large array. It now doesn't have any currently practical use, but it's the same kind of thing for arrays. Did that spec make it across? It's a good question. I don't think it did. No, there's an FBL. Okay, there's another spec that's similar, that it's just not in practical use at the moment, but it does a large array rather than a map structure. So that might be interesting to look at it too if you wanted that, but yeah, not as clean as the HAMP stuff. The HAMP is, we use HAMP in a lot of places in various forms, and it's a really solid data structure. What we need from an ordered data structure is something as solid as the HAMP, and Prolly trees gets us, I think it gets us most of the way there, just not quite as solid as a HAMP, but it'd be interesting to see a spec written up that's in the same vein, that maybe we can then all have a discussion about whether that we can make it better.
Is the generic HAMP without the Filecoin twiddly extra bits, is that in use in places?
No, I don't think anyone's using the Go one.
The
I know
JS
they
one
are
too.
in,
I want to know if like the data exists that is in that structure and people are making use of it.
I know people are using the JavaScript one. I think the JavaScript one, I think, is even being used in the what is that, the Twitter Blue Sky prototype that they put out recently.
Oh, cool.
So that's really interesting. Yeah.
Yeah, I'm wondering, because one of the shortcuts I took with or I don't know, better for worse, shortcut parts of the BitTorrent directory ADL is that, like UnixFS, it eats the rest of the traversal. Like with UnixFS, once you've started, you can't stop being in UnixFS. Once you're in a BitTorrent directory, you can't like stop being in a BitTorrent directory. Whereas like the HAMP ADLs allow you to get out. It's like you did your HAMP, now you render something else. You get out like another node, and then you do whatever you need to with the next node, which is like a different exercise, is a different chunk of the API.
Okay, thanks. I think that is give us some hints to study the ham.
This is
We
William,
study-
also from KenLabs. Following up on this question, can we say that so like IPFS is, sorry, not IPLD, the specification, and the goal or intention is that we try to use polytree to build based on the IPLD node or the bytes, so that we give the different implementation, so that probably from stability or performance point of view, we can see something different. Is that the purpose?
Sorry, the question was, you're asking for the purpose of the specification?
I mean the IPLD, the polytree or the chunky tree, the goal of this idea.
Is that a question for Tao Sheng or for us?
For I think the whole everybody, anyone can answer or clear
I think
about
this is
the mission.
And this is what Rod sort of mentioned, which is like the hamps are nice. There's certain functionality that they offer and some that they don't. They offer key value lookups, which is good.
Yeah.
They don't offer like sorted, interactions though, of like,
Yeah, what the thing that we really want is an ordered data structure that is solid, that works well with content address data, and that's the sort of the golden thing that we're searching for. That when we get that, when we have a sorted data structure that sorts by the keys, it unlocks a lot of potential for building really sophisticated tools on IPLD, because that sorted data structures, sorted key data structures, they're the basis of databases. Once you can build something that has sorted keys, and you can do range lookups, and you can resort things, and you can sort things by different keys, you can start to build indexes, and then you can start to build a database. And once we have that, you can combine these data structures together, hamps and a sorted data structure in different ways. You can resort things, you can have them in different ways to put them together and build really sophisticated tools on top of IPLD. So yeah, that as Adine said, hamps only get us so far. They're really solid, but we can't do anything in terms of ranges. We can't say, for this range, I want to do this, or I want to do things in this order, or I want to collect this subset. You have to know specifically the keys you're getting at.
Okay.
I did see Michael, and they had a hack week. The .storage team had a hack week a couple of weeks ago, and Michael put up a. Let me just see if I can find this. They had an experimental thing. I know he's been working a bit more on polytrees, but this, and they're going to put this in the doc, and I haven't looked at the code yet, but I know Michael has been playing in different times and different approaches to this problem of databases on top of content addressing. This is from a hack week that they did, where they did a sprint on how can you build a database. It's not the first time that Michael's tried to do this. He tried to do one with SQL, which was really interesting as well. So you can find that in his GitHub. But this is trying to use this uses polytrees. Once you have that sorted indexing ability, you can build all sorts of interesting things.
Yeah, Morph shared this project with us as well. So we will look into that. We will look into it. And look, so we are building something on top of IPLD, so it doesn't have to be in line or compatible with any existing library or module. So the idea is that we can come up with some new tool or module, so that we can give more features to the IPLD users, like as you said, the range query, the sort based on some specific node, if I understand correctly, right?
Yep.
I see. Okay. Yeah, thanks.
Yeah, it would be cool if we could get something that is reusable, that's well specified. Then yeah, a lot of potential there.
Cool. I actually haven't heard of the next generation, or like the next database that Michael is building, and from the commits together with Chris. That's interesting. So I should probably also join.
Yeah.
Just as a background, both of them created a database. We were working on a database company together like 10 years ago, 12 years ago. So yeah, I should probably join them.
The ideal, the goal there is getting towards something like a Firebase. So that's the dream, I think.
Cool. Yeah.
Sorry,
All
I
right.
probably have one last question. So
Sure.
before we stop, okay. In terms of the from user point of view, so say that we have IPLD data stored on the internet, on the network. So how can user do the query? For example, if we want to do some range query, say from two, so between this range, we want to fetch some data. So what's the best way to build the interface to the user? We know in Web2 world, probably SQL is one of the most popular interface to developer or even end user. So what's the option for, say, Web3 or IPLD?
That's a really good question. And I think that that's going to require some experimentation. And if you've got ideas about nice interfaces, then that's great. In Go, we have this, we have these developing standards in the Go IPLD Prime library about how you access data, but it doesn't have anything for range queries. So we don't even have that in Go yet for when we're building these ADLs, advanced data layouts, on top of multi-blocks. So I think that's going to require people coming up with proposals for how you would expose that. But it might be interesting to talk to Michael, actually, see if you can grab some time with him to talk, have a meeting with him, and see what his ideas are, because he's been experimenting with this a lot, because it will vary between JavaScript and Go as well. Will, you put your hand up? You got to comment on that?
Yeah, I mean, I would maybe argue that selectors is where that fits in terms of how you query and get subsets of these things. We do have some amount of, I think there is in a selector query a range to get a subset of something that looks like a list. And so if the ADL makes it look like a large list,
yeah,
you could imagine that the selectors for then the range within that large list can give you a subset.
It's true. Yeah, and we could amend that and have the start sat and stop sat for proper range queries. That would be really interesting. But again, we don't have a good selector story in JavaScript. so it really depends on language. It would be the ideal is that we would get good selector support in JavaScript, because we need it for a bunch of places. But yeah.
But if it's an ADL over the data, the server that's going to be doing that is going to be in Go, plausibly. So you've got a few different pieces to solve, potentially.
Yeah, it depends on who you talk to, but yes. It would be nice to have it consistent so we didn't have to worry about these things. But right now, it really is there's a difference in language.
I think so. Although I think some of that is, we'll call it like, like semi motivational. Like a lot of the folks that are working with some of the JavaScript stuff are working in a UnixFS world for a variety of reasons. And so like they haven't felt the need to do a ton of selector things, right? And as the use cases start to develop, then if we have fixtures and we have things that show like this is how we can sort of, here are the tools that are available so that you have to like implement them, but you don't have to think too much about them, then that may make it a little easier. Like a lot of the code that has been ported from one language to another in our ecosystem so far, right? Like round 2 is much, much faster than round 1, because round 1, you're like figuring out what to build. And round 2, you're just like, how do I take your idioms in your language and make them idioms in my language, which is less hard normally.
I'm going to drop a link to selectors in the selector spec in the notes as well.
It's sort of interesting with the using like a list approach, because then it really does show like, oh yes, these are sort of, we're using the ADLs in like a lens sort of way, where like it's the same data, and I can look at it as like a map and get map semantics, and I can look at it as a list and get like list semantics out of it.
Yeah, that's the ideal, and the node interface gives you that, but it doesn't give you the range
Subset.
part of that.
Yeah.
Yeah,
Yeah,
the idea with these multi-block data structures is you want to present it to the user programmatically as if they are using a local data structure, as if it's just reaching into memory. And all the, the fetching of blocks and stuff, you need to abstract that away, because that can either be handled by fetching them out of car files, or fetching them off a CDN, or fetching them through IPFS, DHT. That needs to be abstracted away. It's just a load and a save operation in the background. But to the user, they just need to be, it needs to feel local. That's the ideal there, because once it feels local, then you can programmatically make something that's like a database, but distributed.
All right. Any further questions? All right.
Thanks.
Right. Cool. Thanks. Yeah. Also, thanks for the questions, because it's always great to get in touch with people and talking about those things, because like many people in here have already put some thought in many different things. So it's good if we start the discussion. All right. Cool. Yeah. Then I would say we close the live stream part of the meeting. If you still want to hang out, so after the live stream, we still hang out. If there's any questions that you want to ask privately and not live streamed, feel free to keep in to stay in the room. But for the live stream, I say goodbye and see you all in 2 weeks again. Goodbye, everyone.
Bye. Thank you.